I'm Walt Brown, and tonight I'm going to be talking to you about evidence in our solar system that supports the hydroplate theory. And if you have no idea what the hydroplate theory is, just bear with me. I'll give a quick overview before I get into the evidence in our solar system. This is a picture of ultimate Thule. It's a trans-Neptunian object, and I'll talk about those tonight. This is 1 billion miles beyond Pluto's orbit. This picture was taken in 2019 by New Horizons. It's called a contact binary. These two things had been orbiting each other, but now they're touching each other. How do those things come together? They're moving very fast. How did they come together without destroying each other? Scientists are kind of puzzled by that. Well, it also has water ice on it. So water that's frozen is on this. How did the water ice get there? And I think there's a connection between the water ice and how those things came together, and I'll explain that tonight, and it points towards the hydroplate theory. I want to begin by discussing my background, although Rob's covered it already, most of it, so I'll be able to breeze through that real quickly. Then I'm going to give an overview of the hydroplate theory, and then I'll talk about evidence in our solar system that supports that theory, beginning with the Earth's moon. We'll talk about asteroids, trans-Neptunian objects like ultimate Thule, comets, moons around other planets, and by then we'll be done, and you'll be tired, and we'll open up to questions. But if you have questions as I'm going through this, and if I throw out a big term, I'm going to try to explain every term I throw out. But if you have a question, please ask as we're going through, because I don't want to find out at the end that you didn't understand something I said after the first 10 minutes that you needed to understand. I'd rather stop and answer the question then, okay? All right, my background. Rob's already covered it. Probably the most important thing you need to know about me is my father's Dr. Walt Brown. He's the author of the book, In the Beginning, Compelling Evidence for Creation and the Flood, and he's the author of the hydroplate theory. The reason that's important to know about me is from the time I was a little kid, I was exposed to a lot of the things that you guys talk about. And I feel very fortunate for that. And the older I get, the more fortunate I realize that I had someone to go to and ask questions about. And my father's easily the smartest person I've ever been around. And I've been in academia for a long time, but the breadth of his knowledge is really incredible. And don't ask me questions thinking, oh, you're his son, so you can answer any question I've got about the book. No, I can't. He's the smartest person I know, and I'm way well below that. I spent 21 years in the Air Force. Most of the time I was a pilot. I was also a teacher, and I went to school quite a bit. I ended up earning graduate degrees from George Washington University, MIT. I went to CU up in Boulder, and the military is a graduate school called Air Command Staff College. I have spent a total of 21 years as a professor of astronautics at the Air Force Academy. And as Rob mentioned, I've published some papers that are applicable tonight that I'll summarize on trans-Neptunian objects and the moon's orbit. And occasionally, as we're going through, you'll see some footnotes like by my dad's name and by the papers I wrote. My father's book is the biggest thing I'm referencing. I'm not going to reference everything that I'm using, but at the end, there will be some references there if you're interested in trying to track down the original source. The two places I think I would direct you to the most are my father's book and a guy named Brian Nichols, who has some fabulous videos on the hydroplate theory. And those are what those references are for. This is an appropriate time to get this out of the way. The Air Force Academy requires me to let you know that I'm not representing the Air Force Academy. They're my opinions. They don't represent the opinions of the Air Force, the Department of Defense, or anybody else. I think that's kind of obvious, but they told me I had to say that. So we're moving on. Let me give you an overview of the hydroplate theory. My father hydroplate theory and said it's based on one big assumption of the conditions before a global worldwide flood. And the assumption is that about half of the water that we see in today's oceans was above the crust. The other half was about 60 miles below the crust in interconnected subterranean chambers. How it got that way? God made it that way. And if you start with that condition, everything else can follow from a scientific and physical, just physical laws. He also said that the Earth was relatively smooth with a mountain range. We didn't have the 14ers like we have around here, but about 5,000 foot mountains. Okay, nothing like what we have here. And we're going to talk about what would happen then, but the tidal forces of just lifting the crust up and down would pump so much energy into that water. Eventually it would get really hot. I mean, incredibly hot. And under a lot of pressure, it would become supercritical. And then I'll talk about the sequence of events that would happen after that. But before I do, I want to let you know that this theory, I think, is not only accurate scientifically, it's consistent with the Bible. And I think you need to run theories by the Bible and say, hey, does this support it? And I don't think the Bible was written as a scientific book, but I think it is scientifically accurate. Meaning, I don't think God wrote it and said, I want to teach them about science. It was written because he wanted to teach us about him. But it is scientifically accurate. And we read in Genesis 1:7, so God made the vault and separated the water under the vault from the water above it. And all these verses are going to talk about that initial condition I talked about. In Psalm 24:2, we read, he founded it, meaning the earth, upon the seas. So the crust was above the water. He gathers the waters of the sea together as a heap. He lays up the deeps in storehouses, from Psalm 33:7. Psalm 104:3, he lays the beams of his upper chambers in the waters. In Psalm 136:6, he spread out the earth above the waters. So there are a lot of references to this idea of the waters were separated. And I told you that eventually that water would get so hot, and when it's supercritical, it would start dissolving a lot of the rock around it. But if there was a crack, and that water was able to get through the crack, it would come with a tremendous force, causing the fountains of the great deep. And that's the source that my father proposed for a global worldwide flood. And rain would come down in torrents, and I believe there was no rain even before the flood. And some of that water and rock would go up into space. The water would freeze right away and come down as huge ice dumps burying the frozen mammoths and other creatures. And I think some of it went into space and became trans-Neptunian objects, asteroids, and comets. And we'll focus on that tonight. But you first need to understand what happened at the Earth. This is an artist's picture of what that might have looked like. Noah wasn't drawing this picture. And some supporting Bible verses for this phase of the rupture. In Genesis 7:11, we read, on the same day, all the fountains of the great deep burst open, and the floodgates were opened, and rain fell. Prior to this, I was telling somebody that I think the Bible underestimates statements that, and rain fell, just doesn't do it justice. I mean, Job 38, 8 through 11. The sea bursting forth, it went out from the womb when I made a cloud its garment. Psalm 18:15. The channels of water appeared, and the foundations of the world were laid bare. And Proverbs 3:20. The deeps were broken up, and the skies dripped dew. And finally, 1 Peter 3:6. Long ago, by God's word, the heavens existed, and the earth was formed out of water and by water. By these waters also the world of that time was deluged and destroyed. So the water that was used at the creation was the same water that was used at the flood. So what would happen as this water's rushing up? Well, there'd be incredible erosion right near that opening, and rock would be thrown into space, and sediments would settle out all over the world, creating the fossil record, and that gap would get wider and wider. And eventually it'd look like this. Okay, now after a while, the rain would stop because the water coming out from the subterranean chambers wouldn't have enough force to shoot up through that deep ocean there in the middle of the picture. But the water would keep rising. And that's what we read in Genesis. The rain stopped, but the water kept rising. And the other thing that would happen here is the crust that was gone there, that now sediments are all around the world, and creating the fossil records, burying plants and animals. It's not pushing down on the mantle in the middle of the picture, the bottom of the middle of the picture. But the crust on the side is still pushing down, so that mantle would want to buckle up because there's no force pushing down on it, but force pushing down on the side, and it would look like this. Okay? And that would create the mid-Atlantic ridge, which I'll show you a picture of in a bit. It also would lift the crust closest to that gap a little bit. The crust is really heavy, and it has lubricating water underneath it, and so it would want to start sliding away. Here's an artist's picture of what that may have looked like. And here's a picture of the world without all the sea on it, seawater. So you can see what the middle Atlantic looks like. Down the middle Atlantic, you see a huge mountain range. That's the mid-Atlantic ridge, where I think the continents slid away from. And as they were sliding, the water underneath them that was acting as lubricants would slowly come out, and there wouldn't be enough water, and they'd start getting a lot of friction. And then these continents that are sliding away, pretend I had a whole stack of papers. This is the sediments that have been laid down. As they're sliding away, the friction would stop them, but they keep sliding and they buckle like this, creating the major mountain ranges around the world, like the Rocky Mountains, that run parallel to the mid-oceanic ridge. And it would also create huge trenches and a big ocean basin where the waters from the flood would recede to. Now, I think this, let me move on. I want to talk about the biblical references before I get too far. Supporting verses for this buckling phase that I've just talked about. In Genesis 8, we read, the foundations of the great deep and the floodgates of the sky were closed, and the rain from the sky was restrained, and the water receded steadily from the earth. Oops, what did I do there? I will get back to it. And in Psalm 104, 6 through 9, the waters were standing above the mountains. At thy rebuke they fled. At the sound of thy thunder they hurried away. Can you imagine the sound of the Rocky Mountains buckling? I mean, that would be incredible. Scary. At the sound of thy thunder they hurried away. And I'm sorry, I'm reading the wrong thing. I need to click one more time, one more spot. The waters were standing above the mountains. At thy rebuke they fled. At the sound of thy thunder they hurried away. The mountains rose, the valleys sank down to the place which thou didst establish for them. Thou didst set a boundary that they, meaning the water, may not pass over, that they may not return to cover the earth. Okay, so I think, and I've gone through this really quickly, and I'm not going to delve into it a lot more. I just want you to know, I think rocks and water and organic material and some of the atmosphere was also thrown into space during this time, and that's what we're going to focus on tonight. But before we leave the hydroplate theory on the Earth, I want to say it can explain many geological mysteries on the Earth. We're not going to cover these tonight, but again, if you're interested in that, you can jump to this guy's got a great website, Brian Nichols, fabulous YouTube videos. There are lots of other sources that you can delve into this, but these 25 geological mysteries that can be explained by what I just summarized include one of the ones I think is the biggest one is, where did all the water from the flood come from? I mean, why do we have fossils of sea life on the top of every major mountain range in the world? And where did all the water go afterwards? I mean, you just said it rained a lot, Pikes Peak was covered. You're like, well, where did it go later? This can explain that. It can explain the formation of the mountains, the plateaus, like the Colorado Plateau, the salt domes, oil and coal deposits, the formation of the Grand Canyon, and submarine canyons that are underneath the surface of the ocean, but some of them are longer and deeper than the Grand Canyon. I mean, how did those form if they're under the ocean? The hydroplate theory can explain that. It can explain why the mid-Atlantic ridge that I just showed you and why the floor of the Atlantic Ocean is drastically different than the floor of the Pacific Ocean. It can explain the fossil record, the frozen mammoths. It can explain the radioactive material that Rob was talking about before we began tonight. And I'm not going to get into any of that. And my father's made predictions. And that's the true test, I think, of a scientific theory. Can you make a prediction that is surprising? I mean, I predicted the sun's going to come up tomorrow. No one's going to say, wow, impressed. But if you predict something that no one expects and then it comes true, that's how Albert Einstein became famous. He made a prediction. And when it came true, they're like, who's this Albert guy? And he became famous. My father in 1980 predicted in writing that they'd find pooled water under mountains. That was confirmed 21 years later when salt water was found 7.5 miles below the crust. And in 2008, supercritical water was also discovered 2 miles below the floor of the Atlantic Ocean. No one expected it when my father predicted it, but based on what I just told you, you can see why that was a logical prediction. He also predicted in 1995 in writing, he predicted that deep channels would be found under the Straits of Bosphorus, Dardanelles, and Gibraltar. And those were all confirmed in 1998, 2009, and 2018. Well, we're going to focus on what happened beyond the Earth. But before we leave the Earth, I want to talk about what would this phenomenon have done to the Earth's orbit? Well, if this is the sun and this is the Earth would still make the same path around the sun. My father estimates that only about 3% of the Earth's mass would have left the Earth and not come back and formed all those objects I talked about. That's not that significant. The Earth's orbit around the sun is not going to change. But the Earth went through a lot of heat. There was a tremendous heat. And that heat would have melted rocks, and the heavier elements would have descended closer to the center of the Earth. The crust itself would have been closer to the center of the Earth, and that would change the inertia of the Earth. Just like a figure skater who's spinning, if he or she then pulls their arms in, they start spinning faster, the Earth would spin a little bit faster. Taking the same path around the sun, if each day is a little bit shorter, there could be more days in a year. And I believe that's why there are a lot of ancient texts that indicate we used to have a 360-day year, and now we have 365 days in a year. In fact, there are 14 different cultures that indicate that we had 360 days at one time and exactly 30 days in a month. Today it's 365 days in a year and 29.5 days in a month. Those cultures include the Persians, the Incas, Egyptians, Chinese, Chaldeans, Assyrians, Babylonians, Hebrews, Greeks, Hindus, Romans, Aztecs, Mayas, and Peruvians. And it would make a lot of sense if God created things and it was very good, which we believe, if he made it that there were 360 days in a year and 30 days in a month. In Genesis 1:14, we read that he created the sun and the moon. He said, let them be signs to make the season, to know the seasons, days, and years. And everyone could look up at the moon and say, oh, I know exactly what season it is. Now, what's interesting is the Vedic and Sanskrit manuscripts actually provide explanations for what happened. So listen to their explanations. A cosmic upheaval in the remote past happened. That they say we used to have 360-day year, but the Earth underwent a total upheaval. Sounds like the hydroplate theory I just explained. And as a result, the Earth's period of revolution around the sun in 360 days was changed to 365 days. And they say this also caused the moon to have a serious perturbation. A perturbation is a term that an orbit has been changed from what you would have expected. Something changed the orbit. So it would have caused the moon to have a serious perturbation, and the period of lunation was very probably changed. And I thought, that's interesting. Would it change to what we see today? So I did some calculations, and I assumed that the pre-flood Earth had exactly a 30-day lunar calendar and was in a perfect circle around the Earth. And I worked backwards and said, of that 3% of the Earth's mass that would have been launched into space, if just 1.22% of that 3% hit the moon, that's all it would take to change the moon's orbit from the 30-day lunar month that we had before the flood, I believe we had before the flood, to the 29.5-day period that we have today. In fact, I looked at 6 other parameters of the moon, and they all would be different by less than 0.04% from what we have today. So I think it is very feasible that this total upheaval that was discussed was the hydroplate theory, and it changed not only the Earth's length of a day, and so the number of days in the year changed, but also the period of our lunar month. Now let's look at some other things about the moon. Well, the moon has a thin atmosphere. It's about 10 to the negative 14th of what the Earth's atmosphere is, but there is an atmosphere there. It's just really thin. How did it get there? I'm doing it again. I'm sorry. It gives me 2 slides. The slide I'm about to show and the slide I've already shown. I'll start having to look at the different one. There's also water ice on the moon. Over 1 billion tons of water ice. That's a lot of water ice. Now, a lot of scientists and evolutionists say, well, yes, there are comets that bring the water ice there, and it's been there for billions of years. That's a lot of water ice. And there's some other reasons that we'll get into that I don't think it's been there that long. If you look at the picture of the moon, the near side of the moon's on the left and the far side's on the right. One side of the moon always faces the Earth, that's the near side, and the far side's obviously the other side. The whole moon is covered with small craters, but the near side has huge mass concentrations on it. The far side has none of those. Here's a color picture to show you where the mass concentrations are, indicating some big things hit the near side of the moon. None of them are on the far side. There are about six different big red dots there. And those three at the top, because they're all in a line, it's an indication that they may have happened relatively quickly. If any of y'all remember, years ago, Comet Shoemaker-Levy hit Jupiter. And when I say years ago, it was long before Miranda was. And Comet Shoemaker-Levy got pulled apart by the tidal forces of Jupiter, and then it hit Jupiter, and you saw it looked like a string of pearls going in, and then there were just little dots in a line across Jupiter, indicating it happened relatively quickly. And there are only three of them here, but that's an indication to me that maybe those happened relatively quickly. And if those impacts came from outside the Earth system, the Earth should have shielded the near side, both physically and just gravitationally, but they're all on the near side. And this is something I really find interesting. This is a sample of a rock brought back in 1971 by the Apollo 14 crew to the moon. And they're just walking around on the moon picking up rocks. 4 years ago, a paper came out analyzing part of this rock had a chip in it from another rock. And this paper concluded, it was in the journal Science, which I believe is probably one of the top 2 most prestigious scientific journals there is in the world. And Science published this paper, and the conclusion of this paper is that rock formed in a water-rich environment, liquid water. And you're thinking, well, how did that happen? It's on the moon. The best part. They concluded that rock formed on the Earth, not the moon. But not on the surface of the Earth, 12 miles below the surface. That's phenomenal. I sent that email to lots of friends. Well, this happened. And friends who know how I think it happens. They speculated that they had to explain, well, how did it get to the moon? So they speculated, well, maybe a volcano shot it to the moon. But they also said earlier that it was in a water-rich environment. How does that work out? I think the hydroplate theory is a great explanation. I think there are lots of other rocks on the moon that came from the Earth. And I also kind of think God was thinking, this will be interesting for them to shoot on. So what happened with all the other rocks and water that was launched in space that did not hit the moon? Remember I said only about 1.22% hit the moon. What happened to those? And I think they became asteroids, comets, trans-Neptunian objects, and some small moons around giant other planets. Well, they would leave the Earth and begin orbiting in huge swarms around the largest boulders. It would look like a big beehive of these things moving around. Okay? And they would orbit those larger boulders because they have more gravity around them. And they're kind of heading in the same direction with about the same velocity. As they got further away from the Earth, their sphere of influence would get bigger, meaning their gravity controls more of the area, and that makes it more likely that those things that orbit in them would be captured by them. See, in space, normally, if this is my fists are 2 objects, and this object's coming in really fast, he'll fly in some velocity, really high velocity, he'll shoot by this one, and shoot out the other side with the exact same velocity. However, if the sphere of influence is getting bigger as you go further away, then there's a chance it will be captured as you get further away from the Earth, or later further away from the sun. Also, the water would immediately freeze in space, and there would be small frozen water droplets all around, and also smaller rocks. And so these rocks that are orbiting are going to hit those and lose a little bit of energy and a little bit of velocity that would allow them to be captured by the larger boulder. And these swarms, I think, would have been propelled outward. I'm doing it again. Propelled outward by, if I do it again, just speak up. Click it again. By 3 main forces propelled away from the sun. Solar wind would push them away from the sun. Solar wind is a phenomenon that the light coming from the sun, it can be thought of as a photon with a little bit of momentum. Not much, but a little bit. and it's constant. And so slowly over time, it can push things further and further away from the sun, and they get faster and faster. And there are satellites in space that use this phenomena. They deploy a big solar sail, like the picture on the screen, and the solar sails that are up there are about 30 meters on each side. Well, the swarms that I'm talking about would be like 1,000 miles getting pushed with about the same force from those photons moving away from the sun. There would also be something called the radiometer effect. This is a radiometer. Some of you may have seen it. There's a picture on the screen. When it's in sunlight and it's heated, the sun heats the black side of these veins a little bit more than the white side. There's a little bit of gas in here, and those gas molecules are going to bounce off the black side with more momentum than the white side because it's hotter. And that propels these veins away from the black side and makes it spin. Well, that's going to happen there. And with the swarms, a lot more so because it's got a lot of water vapor around it. It's going to be bouncing off the hot side, pushing it away from the sun. Another force that's been documented in technical literature is very similar to the radiometer effect, but slightly different. It's called the Yarkovsky effect. And this is obviously not drawn to scale. The big yellow ball at the bottom is the sun. The big black ball at the top is a much smaller object orbiting the sun. And like most things in the solar system, the way this picture is drawn, it's orbiting counterclockwise around the sun, and it's also spinning counterclockwise viewed from the northern hemisphere. Okay? Because it's spinning, the hottest part of that object is not at the part that's closest to the sun. It's what we might call 12 noon. It's actually a little bit after noon. Just like around, someone said, what's the hottest part of the day on average? You want to say 12 noon. You'd say maybe 1 o'clock in the afternoon or 2 o'clock in the afternoon. Because the Earth spins, and the hottest part is a little bit after 12. Likewise, the coldest part of the day is not at midnight, but a little bit after midnight. So the molecules that are going to be bouncing off of this object would have more momentum around 1 o'clock. And that would, see the little red arrow there on the orbiting object, the thrust vector would not be pointed directly away from the sun, but it would have one small component in the same direction that the object's orbiting the sun. And that small component would add a lot of energy to that orbit, and it would cause it to slowly spiral away in roughly a circular orbit. Because if you're in an orbit and you want to get to a bigger orbit, the best thing to do is you speed up in the direction you're moving, and that causes you to spiral out to a larger orbit. You're basically adding kinetic energy to the object. Okay, and this would add a lot of energy. And I wanted to give another number before we left this. The radiometer effect and the heat on one side versus the other. You might think, well, it's not that much colder at night than it is in the daytime. That's because we have a big atmosphere here and we've got other things. But on the moon, the average temperature in the sunlight is 240 degrees Fahrenheit. The average temperature in the dark is minus 270 degrees Fahrenheit. That's a pretty big difference. Now, part of that's because the moon doesn't rotate very quickly, but there would be this difference, and it would be slow, and it depends on how fast they would be launched from the Earth and how much water they would have around them. Different things would move at different speeds through the solar system. Most of them, I think, would move in the plane of the ecliptic, which is the orbital plane that the Earth takes around the sun, because the Earth was already moving pretty fast around the sun. It moves about 30 kilometers a second, about 18 miles per second is how fast the Earth is moving. And they would also spiral out in circles. So they would have left in circular orbits moving along that same plane. And we'll touch on that a little bit later. Now let me talk about asteroids and talk about some common explanations for asteroids and problems associated with each of these theories. One theory is that asteroids came from an exploded planet. And that's why we see lots of pieces there, kind of like rubble after a building gets knocked down. Well, the problem with this is asteroids and TNOs together only make up about 2 to 4% of the Earth's mass. So that would be a tiny, tiny, tiny planet. And by their own admission, evolutionists who propose this theory say, well, it's not a lot of rocks. There's a problem with that. It's also way too much energy to explode a planet. If you had an entire planet made of TNT and it exploded, it would come apart and gravity would pull it together. Some people think it was a planet that was trying to form, but it never got enough stuff together, and it's a failed planet that formed. I think this is a little disingenuous because evolutionists can't explain how planets formed anyway. So to say that's one that didn't form, and that's one that formed, and you say, well, how did that one form? They say, I don't know. You can't really say that one. It's a fallacy in logic. Rocks don't merge together. Remember I talked about a rock coming really close to something else and just shoot out the other side? Unless special conditions exist. And the two that I mentioned associated with the hydroplate theory are, if there's a big atmosphere, like water around, it will add aerobraking and allow things to slow down. And if it's moving away from the object it's orbiting, like the Earth, or moving away from the sun, where its sphere of influence is getting bigger and bigger, that will allow it to capture things. An evolutionist wrote, even the Earth's most evolved brains still haven't grasped why space dust condensed into boulders. So if they don't know how they formed into boulders, why would they say the asteroids are a failed planet? And another problem with both of these theories is the asteroids would be pulverized. Evolutionists believe that the solar system is 4.6 billion years old. I think it's a lot closer to 5,000 years, which just would blow their mind. But this is a quote from an evolutionist in a journal. The predicted mean time between major asteroid collisions for each asteroid, not just for all of them, but for each asteroid, is about 5% of the age of the solar system. Therefore, all asteroids should already be highly fragmented unless their origin is relatively recent. And I do agree with that last part. I believe their origin is relatively recent. So let's look at some asteroids, and you kind of decide yourself. Does it follow one of these other theories or the theory that I proposed that they came from the hydroplate theory? Well, first of all, asteroids have moons. There are at least 243 asteroids have moons. 10 of them have 2 moons. At one point, scientists said, there's no way an asteroid can ever capture a moon. They're way too small. They don't have an atmosphere. All these other things. But they have moons. This is a picture of Ida and Dactyl. They're 60 miles apart. That little dot on the right is the moon Dactyl. It's a mile in size. How did that happen? Here's a moon that became kind of famous last year, Didymorphos. If y'all watched, there was a DART mission where we impacted an asteroid. This is the one we impacted. This is a picture taken right before impact. Look at all the rocks on that thing. It looks like a big rock pile. We'll talk about that in a bit. They're contact binaries, just like the TNO I showed you at the beginning, Ultima Thule. This is a contact binary. It's made up of 2 large objects that came together. It was studied by Japan, and I'm going to find a quote. Donald Yeomans, a member of NASA's Jet Propulsion Laboratory, admitted, and looking at this and studying it, it's a major mystery how 2 objects the size of skyscrapers could collide without blowing each other to smithereens. This is especially puzzling in a region of the solar system where gravitational forces would normally involve collision speeds of 2 kilometers per second. Now, I did the unit conversion for you. 1.2 miles every second. That's how fast these things are moving out there. He said, out of these 2 large objects, they came together at an angle and then they were covered with smaller things afterwards. How did they come together without blowing each other to smithereens? Well, my explanation, or I should say my father's explanation, is they were launched from the fountains of the Great Deep in the same direction, roughly the same velocity. They were orbiting each other in this big swarm. The water vapor around them allowed them to lose energy, and they slowly started coming together until they touched. And then all the other things around them came together as well. And my father, based on the hydroplate theory, made some predictions about comets and asteroids. In 2001, he predicted in writing, and when I say in writing, it wasn't like he wrote something down and said, I'll shove this in my bottom drawer. It was in a published book. Okay, so he published these predictions. He said that asteroids and comets would be found to be large rock piles. At the time, people thought, oh no, it's a big solid piece of rock. No, he said there's rock piles with larger rocks near the center and smaller rocks around on the outside, like the pictures I just showed you of those 2 comets. And would often have internal ice acting as a weak glue holding them together. 4 years after he made this prediction, Ceres, the largest asteroid, was found to have a rocky core and mantle made up of primarily water ice. He also wrote, my father, in his prediction, he said, a deep penetrating impact on a large asteroid would release vast volumes of water vapor. Which is surprising at the time because people thought it's a solid rock. And you hit that and water's going to come out? 13 years later, salt and water ice were found on Ceres, and 2 jets of water vapor were discovered escaping Ceres at a combined rate of 3 pounds per second. Water ice has also been discovered on the asteroids Themis and Cybele. And here's a picture of Gault. This is an asteroid. It kind of looks like a comet. There's a trail of dust 500,000 miles behind it. Here's another asteroid. This asteroid was viewed by Hubble telescope, and the lead investigator said they watched it for 5 months, and it, quote, it looked like a rotating lawn sprinkler. Now, the lead investigator admitted some asteroids contain water ice, and sublimation happens, and that could explain this. But he said that's impossible. This asteroid was too close to the sun, it couldn't be water ice. And I think the reason he said that is, he thought, this has been there for 4.6 billion years. If it ever had water on it, it should all be gone by now. It can't be water ice. He had no explanation for what it is. I think it's water ice, and I don't think it's been there for 4.6 billion years. My father also predicted in 2001 that most rocks would be rounded on comets and asteroids. And this is a picture of Comet 67P. The European Space Agency landed on this and brought back samples. We'll talk a little bit more about it later. It's also contact binary. 2 objects came together at a large objects are underneath this rock, and they came together at a weird angle. Here's a close-up view of that. And you see the little bumps in this little crevice. The scientists studying this described it in a number of ways. They described it as, it looked like it has goosebumps on it. And they said it had large rounded boulders that looked like dinosaur eggs. They weren't dinosaur eggs, they just said they were boulders that were rounded. And they had no idea, why would these boulders be rounded? Well, can anyone here figure out why they might be rounded? Yeah, my father predicted based on the hydroplate theory. Lots of water shoot things up would create tremendous erosion. Not like if you walked up in the Rocky Mountains and picked up a rock from a stream that's been there for a long time, it'd be kind of smooth. Well, the water in the fountains of the Great Deep was shooting a lot faster than that water in the mountain stream. And so this is really puzzling for a lot of scientists. But again, if they just read my dad's book 13 years before, they would have said, oh, that's what I think is going to happen. Now we're going to change gears and we're going to talk about meteorites. And a meteorite is basically a small asteroid that has impacted the Earth. I think returned to Earth from where it came from. And when that happens, they're not always fortunate enough, but they like to quickly contain the meteorite and get it into a lab where it's not going to be contaminated, and then cut it open and see what's inside. Most of them contain salt water. This is a quote from a meteorite that was examined just last year in the United Kingdom. The scientists studied it said it is, quote, very, very similar to the composition of water in the Earth's oceans. That's interesting. They contain salt crystals. Meteorites have rocks in them that indicate that the meteorite was at least 1,300 degrees Fahrenheit for a long period of time, with a peak heat of at least 3,000 degrees Fahrenheit, and then rapidly cooled. Well, in the subterranean chambers, I said, tremendous heat. Then it'd be launched into space. In space, it would cool off really quickly. They could explain that. They find diamonds on these, not tons of diamonds, but some diamonds. And a diamond is a pure form of carbon, which is an indication, carbon's an indication of life. And diamonds also require extreme heat and pressure. Limestone is found on meteorites, and limestone only forms in liquid water. Where do you get liquid water in space? Well, in the subterranean waters, you would have lots of liquid water with limestone and then be thrown into space. There are also signs of life on meteorites. Amino acids have been found on meteorites with long strains of carbon-based compounds. There are excessive amounts of left-handed amino acids, and Their amino acids are both left-handed and right-handed, but life is almost exclusively left-handed amino acids. And on meteorites, they find much more left-handed amino acids than right-handed ones. DNA components have been found on 12 different meteorites. Sugars have been found on meteorites, and bacteria has also been found on meteorites. Fossils of bacteria have been found on 3 meteorites, and 78 types of living bacteria have been found on 2 meteorites. Now, you look at those last 2 bullets, which one's the most surprising to you? Fossils on 3 or 78 types of living bacteria on 2 meteorites? Just show of hands. Who thinks the fossils? Who thinks the living bacteria? Okay, I would say the living bacteria too. However, evolutionists who look at this, they think, oh, those are all contaminated. All 12 of those ones that had DNA, they got contaminated. All those ones that found bacteria, they got contaminated. And I'd say, even the fossils? I don't know how you contaminate and put fossils of bacteria on it. And some evolutionists look at this and they're kind of excited about this idea because they have such a hard time explaining how the first cells of bacteria formed on Earth. And now they can say, oh, it came from space. And I think that's just kicking the can down the road. They have to then explain, well, how did they get on that one? So I don't think that really solves the problem they have. Life is complicated. It doesn't just happen by chance. Now I'm going to change gears and talk about trans-Neptunian objects. Trans-Neptunian objects are just like asteroids. They tend to be a little bit bigger, but the key thing is they're beyond Neptune's orbit. Their average distance from the sun, which is called the semi-major axis, is more than 30 astronomical units from the sun. That's what AU means. One astronomical unit is the distance the Earth is from the sun. Neptune is 30 astronomical units away from the sun. So if it stays an average distance beyond 30 astronomical units, it's beyond Neptune, hence the word trans-Neptunian object, or TNO. Okay? Let me give you some common explanations for where TNOs came from, and then problems with each of them. Some people think they formed in their current orbits from planetesimals. That's that space dust that no one can figure out how it formed into rocks and boulders. But by their own admission, those planetesimals would be too spread out that far away from the sun, and they'd never come together. Some other evolutionists think that TNOs must have formed closer to the sun, and then Neptune moved away from the sun and scattered them into the orbits that they're in now. But a problem with that is there's no one, and I've dug for it, no one can explain why Neptune would move away from the sun. It's a huge planet. And if it did move away from the sun and scatter these TNOs in their orbits, it might fling them out to a higher orbit, but it would just be an elliptical orbit where it'd come right back down to 30 astronomical units and then go back further down. Their closest distance to the sun at most would be 30 astronomical units. And some of these are well beyond 30 astronomical units. They don't get close to Neptune today. Also, there are a number of trans-Neptunian objects that orbit each other. They're called binaries. And some of them are referred to as ultra-wide binaries. They're so far apart, they're very fragile orbits. And if they came close to a giant planet like Neptune that would fling them out to the orbit, the scientists have said, oh, it would strip them apart and there should be no binaries in the trans-Neptunian objects. There should be no trans-Neptunian binaries or TNBs if this happened. Finally, some people think they formed in their current location by collisions. So they just were out there and the rocks were hitting each other. Well, problem is the collisions would happen too infrequently to cause them to form. They would pulverize the TNOs, they'd be destroyed, and the binaries would all be separated from those collisions. So those are all problems. Let me quickly tell you how I think they formed. Well, actually, I'm going to go through my research and then I'll tell you that. Before I do that, though, I want to talk about the most famous TNO, Pluto. You got to have a cool name to be famous, and Pluto's got a better name than all the other ones. It's not as big as you might think. It's only 0.22% of Earth's mass. It has 5 moons. And it's difficult to explain why TNOs have any moons, but Pluto has 5. It has an atmosphere, and it's losing about 500 tons of its atmosphere every hour. And it's losing the atmosphere because the solar wind, the same thing that I think pushed these swarms away from the sun, the solar wind is blowing out and the photons are pushing it away. How long did it have an atmosphere if it's losing it that fast? Where did the atmosphere come from and how long has it been there? I don't think it's been there that long. Again, about 5,000 years. And it came from the atmosphere that was blown into space at the time of the fountains, the Great Deep bursting forth. It has mountains of water ice, lakes of nitrogen liquid ice, and frozen carbon monoxide lakes. It has towering mountains and an absence of craters. One of the scientists, Jeff Moore from the New Horizon teams, said, and I quote, "This is one of the youngest surfaces we've ever seen in the solar system." Another scientist said, "It's surprisingly young." I think they'd be really surprised at how young it is. Charon, Pluto's largest moon, has crystalline water ice on it. So they're crystals. Well, crystalline water ice only forms at temperatures above negative 260 degrees Fahrenheit. But the temperatures out there now are negative 370 degrees Fahrenheit. So at one time it had to be quite a bit warmer. Also, after just 40,000 years, ultraviolet light and cosmic rays should have randomized these ice molecules, and they wouldn't be crystals anymore. So that would put a maximum age of this moon of Pluto of 40,000 years. Again, we're getting closer to what I think the age is. Remember, that's just a maximum. It could be less. So now I want to summarize my research, and then I'll delve into it. And as I said earlier, I published 3 papers on the orbits of trans-Neptunian objects. If you just want the big picture summary, I concluded they haven't been in their present orbits very long. And I put a maximum time of 3 million years. And if you're a young Earth creationist, that's like forever. But if you're an evolutionist, that's like just a split second. I also said there's a lot of evidence that the TNOs came from inside Neptune's orbit. And I'll explain why. But if you get lost in the weeds, if I throw out a term you want me to explain, stop me. I'll try to explain them all. But I want to explain why I included this.
First of all, there are lots of problems beyond Pluto's orbit. Some TNOs are extremely far away from the sun, and then similar orbits. For example, this is one of the most famous ones. It's the furthest out, Sedna. It has a semi-major axis. That's what A is. It's the average distance from the sun of 524 astronomical units. Remember, the Earth is 1 astronomical unit from the sun. Neptune is 30 astronomical units, and this averages 524 astronomical units. Its closest distance to the sun, which is called perihelion, that's what the little Q symbols for, is 76 astronomical units. So the closest it ever gets to the sun is twice as far away as Neptune is. So the idea of Neptune flinging them out there doesn't work. It's about 618 miles in length. There's some other ones out there. 6 of them, or 9, depending on how you want to count them, are in pretty similar orbits. Their argument perihelion, bear with me, I'll explain what that is. It's the little omega, is near 0 degrees for many of these 6 or 9 that are way out there. Here's a picture to explain what argument perihelion is. The green plane is the plane of the ecliptic. That's the path that the Earth takes around the sun. Okay? The blue plane is the plane of an orbit going around the sun other than the Earth. And you notice on the top right there's perihelion labeled. That's the closest point it comes to the sun. As that orbital plane cuts through the plane of the ecliptic, heading to the northern hemisphere, an angle from there to where perihelion is, it's that little omega, it looks like a W. That is argument of perihelion. So it basically tells you where perihelion is. Now, before I tell you, what would it mean if perihelion from the picture was 0 degrees? Where would perihelion be? In the plane of the ecliptic, as the object's moving north. Right, and that's the big takeaway, okay? They've also found that these objects, 6 or 9, depending on which ones you want to include, have about the same inclination. And inclination is just the tip of these 2 orbital planes. So they're tipped about the same. And studies have shown it's not due to observational bias. Well, I generated a plot that kind of shows the same thing. This shows the argument of perihelion being clustered. The plot at the bottom here, on the x-axis is the semi-major axis, the average distance these objects are from the sun.
and all the dots are trans-Neptunian objects. The larger dots are the 9 with the largest semi-major axis. And you see a thin vertical line. It comes down at 200 astronomical units. I just said anything beyond 200 astronomical units, I'm going to say, is a long period trans-Neptunian object. And all the other dots are the other ones. Those large ones, the ones with the largest orbit, have an argument of perihelion of about negative 18.6 degrees plus or minus 55 degrees. The probability that that would happen by chance is 0.07%, that they'd be clustered that close together anywhere is 0.07% chance. And as a quick summary, that's what argument of perihelion is, okay? And you guys were right when you said A. It means they're kind of close to the plane of the ecliptic. Well, I did something that no one else had done, and I said, I'm not just going to look at just those 9 that are way out there. I'm going to look at every trans-Neptunian object that stays outside of Neptune's orbit. So this is a histogram at the bottom, and I included the white bars or every TNO that has a radius of perihelion greater than 30 astronomical units, meaning it stays beyond Neptune's orbit. Pluto actually cuts inside Neptune's orbit, so this wasn't included. And most of the scientific literature in this area excludes anything that goes inside Neptune's orbit because that might change what you're looking at. There are about 1,600 of these at the time I did the study. The x-axis, it's a histogram, so the x-axis represents what's the argument of perihelion, and I have degrees ranging from negative 180 to positive 180, because that angle can vary, and each of those buckets is 10 degrees in width. The y-axis is how many TNOs are in each bucket, okay? And those are the white bars. The black bars are those 9 long-period TNOs we already looked at, but because there are only 9 of them, they wouldn't show up on the y-axis at all, so I multiplied them by 10. And you see, the white ones cluster around 0 degrees and 180 degrees. All of them. It's not just 9 of them that are clustered together, but there's a real big peak at 0 degrees and another peak at 180 or negative 180, depending on how you want to look at it. And I determined statistically that this matches 2 overlapping normal distributions centered at 0 and 180. And I also determined that those black ones down in the picture, the long period TNOs, could have come from that same population of the distribution. And once again, looking at the picture now with little omega, what does it mean if little omega is close to 0? It means it's in the plane of the ecliptic, moving north. If little omega is close to 180, it means it's in the plane of the ecliptic, moving south. And that's the big takeaway. I also was the first person to notice there's another orbital element that's kind of similar. It's called the right ascension of the ascending node. This is a similar picture. The x-axis is the semi-major axis, the average distance these things are from the sun. The y-axis now is what's the right ascension of the ascending node. I'll show you what that is in a bit. The large dots are the largest orbits, and they're clustered around 123 degrees. That's an easy number to remember, just round it to 123 degrees. The chance of that happening, the probability of that happening by chance is 0.09%. This is what capital omega is, the right ascension of the ascending node. There's a reference point used for all astronomers and anyone who's dealing with orbits called the first point of Eris. It's a star way out there that lies in the plane of the ecliptic. And if you draw an angle from that vector going out to that star to the place where the object breaks through the plane of the ecliptic heading north, that angle is the right ascension of the ascending node. So it basically is a measure of if the orbit's tipped like this relative to the plane of the ecliptic, is it tipped like this, or like this, or like this? It's how it's swiveled, the orbit's swiveled around, okay? And they seem to have a similar orientation, those long ones. But once again, I looked at all of the trans-Neptunian objects. This is similar to the plot that I showed you before. The white bars are all the TNOs that remain beyond Neptune's orbit. And you notice, and the black bars are the longer period ones, multiplied by 10. The y-axis is how many are in each of those buckets. A majority of them tend to be between 20 and 180 degrees. They're not evenly distributed, like they should be if they've been up there a long time. And there's a peak right around 120 to 140 degrees. Now, I told you most scientists are only looking at the 6 or 9 of these that are the furthest out there. A very famous paper was published about the same time I came out with this paper, and they only looked at 6 of them, and they said, those 6 that are way out there, they're in the same orbit, really close to the same orbit. They've been there for 4.6 billion years. Something has to keep them in that orbit because they would be changing. And so they proposed, and you may have heard about it, Planet 9, a giant planet 250 astronomical units from the sun, about the size of Neptune, that we haven't discovered yet. And the gravity from that planet is keeping those in that spot. What they failed to realize is it's not 6 of them that they have to explain why they're clustered. It's all of them. None of them are uniformly distributed. And I wrote a paper where I propagated all the trans-Neptunian objects forward and backward in time, based on small perturbations from the giant planets like Jupiter, Saturn, Uranus, and Neptune. They all would change slightly, and just over 3 million years, if you go forward or backwards in time, these 2 charts that I just showed you should be relatively horizontal, and they should be evenly distributed, but they're not. Why? I concluded in my paper they haven't been there for more than 3 million years. So let me summarize real quickly. The TNO studies that I did, I said neither argument of perihelion nor the Rice-Socini nodes uniformly distributed, and they should be after just a few million years. Argument of perihelion is clustered near 0 degrees and 180 degrees, which indicates something near the plane of the ecliptic may have perturbed the orbits. I think they moved in circles out, spiraling out until they got there, and then they got flung up or down. Rice-Socini node is clustered around 120 to 140 degrees, which is very similar to Neptune's orbit. It has a Rice-Socini node of 132 degrees. And again, those are what those angles represent. So then I proposed a theory. And I said TNOs recently migrated past Neptune. Many were pulled close to Neptune, and as a result, its orbit is tipped about the same as Neptune. Its swivel is about the same, resulting in a Rice-Socini node close to 132 degrees. That's why there's a peak between 120 and 140 degrees. And again, that's a reference if you want to look at it, other than it's just similar to Neptune. Some of them came very close to Neptune, and Neptune gave them a gravitational boost. And that gravitational boost, if it flung them out, would have increased the size of the orbit, the semi-major axis, and the eccentricity, meaning it would no longer be a circle, it would be along ellipse. About half of those that got that gravitational boost would have been shot above the plane of the ecliptic, resulting in an argument of perihelion close to 0. And about half of them would have been flung below the plane of the ecliptic, resulting in an argument of perihelion close to 180 degrees, which explains the histograms that I showed you before. I went on and postulated that many of these continued moving past Neptune due to this force that caused them to migrate away from the sun. The force that I've explained is the Yarkovsky effect, the solar wind, and just the radiometer effect. They had enough momentum as they're moving through the solar system that they continued moving past Neptune, resulting in a radius of perihelion that's now beyond Neptune. And I also said all those long period TNOs that have the same value of omega close to 0, they just came close to Neptune about the same time in orientation to give them the same inclination and the same argument of perihelion close to 0. That's why none of them have one close to 180. And I also said the widest binaries, the trans-Neptunian binaries, the ultra-wide ones, never came close to Neptune or any other planet. They just moved so fast through the solar system, they avoided that gauntlet. Okay? So based on this theory, what would you expect the TNO parameters to look like? Well, I said the TNOs that would migrate faster through the solar system would travel further. They would go farther after they pass Neptune. Therefore, they should have a larger radius of perihelion than the ones that did not migrate as fast. They would also be less likely to be perturbed by a planet because as they go faster through here, they're less likely to come in contact or come close to a giant planet like Neptune or Jupiter or Saturn or Uranus. Okay? If they were less likely to be perturbed, I would expect that they would be more circular because they spiraled out in circular orbits. And so the eccentricity should be closer to 0. Eccentricity is a measure of how non-round they are. They should also be closer to the plane of the ecliptic. If they were spiraling out near the plane of the ecliptic and they were never perturbed, they would still be in the plane of the ecliptic. In contrast, Those that move slower away from the sun, probably because they have less water around them, less of the Yarkovsky effect or the radiometer effect, or they were smaller swarms, they wouldn't travel as far after they got to Neptune. So their radius of perihelion would be closer to 30 AUs than the other ones. And they would be more likely to have run into a giant planet like Neptune and come close to that and been perturbed and flung above the plane of the ecliptic or below. And they would be more eccentric and have higher inclinations. Okay, so let's see if the data supports this theory. Here's a distribution of the eccentricity. This is another histogram. The bottom of the x-axis, way below the x-axis, is what the radius of perihelion is. Beginning on the left, it's 30 astronomical units, and it goes out to 42, and then I just lumped everything from 42 to 81 astronomical units together. The next line above that x-axis is how many TNOs are in each bucket. And you see the smallest number is 81. So there are a number of TNOs in every bucket. And then I wrote down the percentage of those TNOs in each bucket that are almost a circle. And that's what's shown in the plot. So the y-axis is what percent of them in each of those buckets has an eccentricity less than 0.01. A circle has an eccentricity of 0, and the more elliptical it gets, the higher the eccentricity is. So if it's less than 0.05, it's really, really close to a circle. And you notice between 30 and 34 astronomical units, none of them are close to a circle. I think that's because they move slower, they didn't travel as far, and because they were moving slower, they're more likely to be perturbed by Neptune or another giant planet. In contrast, on the right side of the chart, almost 80% of the TNOs that have a perihelion, the closest distance to the sun, is between 42 and 81 astronomical units. 80% of those are almost circles. And the reason I think that's true is they move so fast through the solar system, many of them, 80% of them, were able to get through without coming close to a giant planet. So they're still almost perfect circles, and they're moving so fast they moved well beyond Neptune. Now let's look at the inclination. Same plot, but now on the y-axis, it's what percent of these in every bucket have an inclination less than 5 degrees. So they're really close to the plane of the ecliptic still. And again, those that travel the slowest would have the smallest radius of perihelion. They would be on the left side of this chart. And you see all the way out to about 39 astronomical units, that's about 20% of them lie close to the plane of the ecliptic. But when you get further out, beyond, say, 40 astronomical units, it's like 60 to 75% of them lie close to the plane of the ecliptic and have an inclination less than 5 degrees. Again, those that move the fastest were less likely to be flown above or below the plane of the ecliptic, so they are still have a small inclination. And what about the binaries? Well, I think the ultra-wide binaries, and scientists unanimously agree, they never could have come close to a giant planet. So if the binaries never came close to a giant planet, these ultra-wide binaries must have traveled faster. Therefore, their radius of perihelion should be relatively large compared to the other TNOs. They wouldn't have been perturbed at all. Therefore, they should have a small eccentricity, be close to the circle, and have a small inclination close to the plane of the ecliptic still. And that's exactly what we see in this chart. You can see there are 7 ultra-wide trans-Neptunian binaries. Their average radius of perihelion is 42.5 astronomical units. All of them have a radius of perihelion that's greater than 41.1 astronomical units, which is quite a bit larger than the average of all the non-binary TNOs of 37.7. Their average eccentricity, these 7 binaries, is 0.04. So on average, they're really close to circle. And the most eccentric one is, all of them, are less than 0.09 in comparison with 0.11 for the non-binary TNOs. The inclination is really interesting. All of them have an inclination less than 4.8 degrees, so they're all near the plane of the ecliptic, with an average of only 2.6 degrees. But the non-binary TNOs, some of which did make it through the solar system, I think, without being perturbed, but a lot of them were perturbed, their average inclination is 12.5 degrees. Now we're going to switch back to comets. I told you when I went through the TNO stuff, I was going to get into the weeds. But the big conclusion I made is TNOs haven't been there very long, and they came from inside Neptune's orbit. And now you know why I said they came from inside Neptune's orbit. So now we're going to switch to comets and we start talking kind of big picture things again. The most common theory for comets is they came from an Oort cloud. Oort came up with this idea. He said there's a cloud of comet material 50,000 years from the sun, way, way out there. Why did he propose that? Well, studies have shown that Jupiter there's a family of comets called Jupiter's family. There are over 400 comets there. They have a life expectancy of about 12,000 years. Yet, there are about 400 of them there. If the solar system is 4.6 billion years old, why do we see comets? We have to have another source of comets. So Oort said, there's the stuff out there, and every now and then some of that stuff gets thrown in here and becomes a comet. Well, there are problems with that. First of all, it's never been observed. You can't observe something that far away. And there's no explanation for how it ever got to the inner solar system. Some people say a star may have passed by and pulled it out of the Oort cloud and flung it to the inner solar system. Well, if that had happened, way out here where it gets fly out, it'd come here and fly around it and go way back there. It would never end up down around Jupiter. Well, let's look at the composition of comets, and I think you'll agree the hydroplate theory is a better explanation. This is the picture of the comet that I told you the European Space Agency landed on and brought back samples. They determined it has very low density. They said it's 72 to 74% empty space. It has sodium on it, salt. Crystalline silicates indicating that at one time its temperature was more than 1,300 degrees Fahrenheit. How does something get to 1,300 degrees Fahrenheit if it's way out in the Oort cloud? It has minerals on it that only form in liquid water. That's a problem with the Oort cloud as well. 16 different organic compounds were found on it and brought back. I think the hydroplate theory is a better explanation than the Oort cloud. Now let's talk about moons of other planets. Astronomers accept that smaller moons of giant planets are likely captured asteroids. Enceladus, one of Saturn's moons, has jetting water containing salt coming from it, and organic material is found on its surface. Diode, one of Saturn's moons, also has subsurface liquid water under 100 kilometers of ice. And Mars has two very, very small moons. Phoebus, one of them, has very low density, indicating about 30% empty space or ice. We don't know yet about the other one, but I think it's going to be the same. And outgassing has been detected on both of Mars' moons. Outgassing is when, like a comet comes close to the sun and the water vaporizes and comes out from it. Water ice has also been found on Mercury and on Mars. And that's especially interesting that Mercury has an average temperature of 350 degrees Fahrenheit, but it has water ice in its craters, the craters that never see the sun. I think the fountains of the Great Deep launched some stuff that got onto Mercury. It evaporated really quickly, settled. The ones that settled in the craters that never see the sun turned to ice. The other stuff kept evaporating until it all ended up in the crater that doesn't see the sun. My father also made some predictions based on the hydroplate theory, predictions in writing in a publicized book, a public book. He said Planet 9, that proposed planet, would never be discovered by the date predicted. They predicted it would be discovered within 2 years. That 2 years ended 6 years ago, and they're still looking for it. He predicted in 2001 that the soil erosion channels in Mars would contain salt. At the time, we could see erosion channels on the surface of Mars, indicating that water had flown there. And he said, I bet you're going to find salt in those channels. The water will have evaporated, but the salt would still be there. And that was confirmed 3 years later, salt in the erosion channels of Mars. So in conclusion, I've covered a lot of material. After giving an overview of the hydroplate theory, we talked about evidence that supports the hydroplate theory and a young solar system, and frankly, a global flood related to the moon, asteroids, trans-Neptunian objects, comets, moons around other planets, and other planets. And I would like to open up for questions. You guys have been kind of quiet. I've been talking too much. Here's some references that I can show the other one. But what questions do you guys have for me?
So if you're gonna ask a question, let me know that you want to ask a question, I'll run this mic to you before you start talking, okay?
Is your father still living?
He is.
How old is he?
I wish I looked that up before I came here. I think he's 86.
Wow.
And he may see this, and if I get it wrong, he'll correct me.
Where is he living?
He's in Phoenix.
Okay.
He doesn't do speaking engagements anymore, though.
Could you talk a little bit more about Planet Nine? And
Yes.
why it should not exist? Or-
The only reason for believing it's there is when you look at. Let me go back. There's got to be a better way to go back faster. But the way this is set up. When you look at the clustering of those objects, these, they say, hey, those, and they only looked at the six furthest on the right. They said they all look like they're in the same orbit. They would change over 4.6 billion years. They would change slightly, similar to the study I did. And they said, so something has to be holding them in that orbit. And they said, maybe another planet's gravity is holding it there. And they gave very specific spot of where that orbit would be, where that planet would be. And that's why they said you should be able to see it within 2 years. And it created a lot of excitement. I think it's much more exciting to say I predict there's another planet than to say I predict there's not. But I predict there's not. Not for the reason they give. There may be another planet discovered sometime, but they're speculating. The only reason they believe that planet exists is because they can't explain how these objects are clustered together. And I think they're clustered together because they haven't been there long enough to slowly move away from each other due to the small changes from Jupiter, Saturn, Uranus, Neptune. Oh, the other thing about Planet 9, we don't see anything in our solar system that we've been watching that is affected by it. And when I did that study where I propagated all the trans-Neptunian objects forward and backward in time, I also said at the end, let's say there's a Planet 9 there, and I put that into my model. At the spot where they said it still doesn't keep them together. And they're trying to they did that to explain why 6 of these would stay in the same orbit. But when I showed this picture, it's a lot of them that are not uniformly distributed. So I hate to burst your bubble if you're really excited about Planet 9. It's also interesting, one of the people on that paper, the most famous guy, his name is Brown, no relation. But he's also one of the people who decided Pluto's not a planet. And I agree with him on that. I don't think Pluto should be classified as a planet. Otherwise, you've got lots of other things that are planets too. But now he's proposed Planet 9. Rob, the gentleman next to you. Question.
Thank you for coming, Dr. Brown. I've read your father's book since about 1990. I've studied this quite a bit. I'm very impressed with everything I see and hear. But one of the biggest problems that people have with the Hydroplate theory is for the mass to escape the Earth, at what velocity does it really need to go into orbit and then gradually spiral out? This is one of the biggest complaints that I've heard about it. Can you answer that question, please?
Do you want to know the velocity it needs to escape? Or questions about how it got to that velocity?
Both.
Yeah, I thought so. Unfortunately, I've learned the velocities in kilometers per second because that's how I teach. I've converted them to miles per second on my sheet, so I'm referencing that. Okay, the Earth is moving, I told you, about 30 kilometers per second around the sun. That equates to 18 miles per second. 7 miles per second is what's needed to escape the Earth, to escape the Earth's gravity. My father speculated, and it seems very reasonable to me, that the asteroids and TNOs were launched at velocities up to 10 miles per second, which is very high, and I'll get to that in a bit. And comets were probably launched even faster than that, based on the orbits they're in, which I didn't get into tonight. They don't all lie near the plane of ecliptic. They were launched about 30 miles per second, up to that speed. To give you an idea, to escape the sun, you need to leave the Earth at about 32 miles per second. So I think most things are launched they're out there at least 7 miles per second, but all the way up to some comets around 30. Now, how did that happen? I may have to direct you to one of Brian Nichols' videos, but there's a piezoelectric effect that happens in the crust when like in earthquakes, and it's like atomic bombs going off all around the crust during this rupture phase. It would add tremendous energy to the already uh, explosive water in the subterranean chambers. That would be supercritical, but when the crust would not, it wouldn't just come out and the guts. The crust would be flapping as the water underneath is coming out. So it'd be like putting your hand on the hose, taking your hand off, putting your hand on the hose, taking it off, and it would come in spurts. I don't think it'd be a constant thrust. Uh, but the calculations are in my father's book, and Brian Nichols, I think, does a good job of explaining that velocity. And I'll show you at the end a link to his videos.
Thank you.
Yes. And you're right, that is an objection people have to hydroplate. That's a really big velocity.
Lots of questions from the YouTube channel.
You're right.
Okay, let's start
It
with
means somebody's listening.
first one's from Simon. Roughly how much force would the fountains of the Great Deep exploding be? So you kind of already
I think he means the velocity.
Yep. Let's see here. Second question. How would the fountains of the Great Deep exploding affect the other planets' orbit and the sun? And he asked this during the presentation. So
Okay. I did the calculations on the rock and water that would have hit the moon and how it would have changed its orbit. I did not do the calculations on how it changed the orbit of another planet. I don't think it would change it much at all. The planets are much more massive than the moon, and less debris would have hit those planets.
okay. And from Nigel Fisher, is Walt still working on the online edition of the book?
No, he is not. In fact, right now I don't even. My parents have moved into a retirement place, and I don't even know if they have a computer hooked up. My brother-in-law Jim has kind of taken over the reins of trying to get the ninth edition published, and he has 5 copies right now of the ninth edition, which is about 50% more pages than the eighth edition. And I commend my brother-in-law Jim for doing this. I think it's going to be a huge burden for my father to know that it's in print. And I'm anxious to get my hands on one of those. I'm going to be one of the editors who looks for the final time, looking for any mistakes before it gets into a publisher.
Great. Yeah, looking forward to that myself. Next question is from Abundance by Design Permaculture, LLC. Biggest skeptical argument is too much heat energy. What are your thoughts?
Too much heat energy in the Earth, that there'd be so much energy and heat.
Yeah, it says too much heat / energy.
Well, I think there would be a ton of heat, and that's what launched it. And that's what melted part of the Earth and caused Earth, the heavier elements like nickel and iron, to move towards the center of the Earth and cause Earth to move faster around. If the concern is there's too much heat that would cause everything on the Earth to die, well, it would be lots of water, and a lot of that would go into space and then freeze and come down as ice. So, some people talk about where we're losing our ice is melting all around the world. It might be a good question to ask, well, where did all the ice, how did we ever get all that ice? And I think, yes, there would be a lot of heat released, but a lot of that would have come down as ice. After they was launched into space, would have come down as ice. And no, I don't think the Earth would be too hot for Noah and his family to survive on the Mark, if that's what he means. I'm not sure.
Yeah, I think so, because I've heard that myself, and I love the fact that Dr. Walt Brown's thesis for his PhD was in heat transfer.
Yes. He watched water boil a lot. I'm joking. Once the water boils, okay, just started. I never read his thesis.
Okay, and just 2 more here. From Ben banjo accordion, when did the Earth change from 360 to 365? Because those ancient 360 days cultures were post flood. So why didn't they use 365?
Quick question. I think I think Noah and his family got off the ark and thought there are 360 days in a year and 30 days in a month. No one, God didn't tell them, as far as I know, that things changed. And after a few years of that, they would start thinking the growing season's not happening when it normally happens. And it would take everyone on the earth quite a while to figure out it's no longer 360 days in a year, it's 30 days a year. And I've read some of those texts, Egyptian texts do that. They go through and say, we were off and we had to add some days to get back to it. And so it took them a while to figure out 365 days. But I think word of mouth, everyone knew it's 360 and 30 days. And if you started living all of a sudden tomorrow, and instead of 365 days in a year, it was 390 days in a year, you wouldn't know about it for quite a while. And you'd be telling your kids it's 365. And after 10 years, you would notice a difference. It's
Yep.
now snowing in July, and it's hot in January. Something's changed.
Okay, last one on the YouTube so far is Simon. Do you believe that the flood or post conditions of the flood killed the dinosaurs, or what did it? Because both Behemoth and Leviathan are mentioned in the post flood book of Job.
I'm glad he mentioned that because, yes, they are mentioned in Job, and no, I think two of every animal were on the ark. Now, if you read a kid's book, it has giraffes with their necks sticking out the windows and elephants. There's nothing to say that they had to be adults, and they may have been dinosaur eggs. And I think that's very feasible. Now, so what killed them? Well, any species where there's only two of them, a male and female, is pretty vulnerable to extinction. So there are lots of things that could have killed them. But I think a likely thing that killed the dinosaurs is there was a lot of vegetation after the flood. And if you eat grass all day and you're the size of a house, there's not much grass. So I think that's what killed them. But let me speculate.
I have a question myself now, and then I'll hand the mic back. So, just what are your thoughts on? And I'm looking at the pronunciation here, and I'll probably say it wrong. The that interstellar object that they discovered not that long ago, Oumuamua. Are you? Have you come up with a speculation?
One again, because
It's the first object that supposedly is the first interstellar object to visit our solar system.
Yes. Okay. It's Mula Mula, if I remember correctly, was first observed around Jupiter's orbit. And it's coming in, and they say, hey, this is on a hyperbolic orbit, meaning it came from outside of our solar system. And it's coming in, and it's never has been in the solar system. Hyperbolic orbit means it comes by one time and it's gone and it's never comes again. Therefore, the argument would be it couldn't have been launched from the Earth because it wouldn't. If it was launched from the Earth, it wouldn't be on one of those orbits. Well, if it was launched from the Earth, it went way beyond Neptune, and then started coming back, and had a perturbation because it came close to something like Sedna, or any of those TNOs that are way out there, or even Pluto, or Neptune, it would speed up. It could speed up. And so it could be moving faster at the time we first observed it. When we first observed it, I believe it was around Jupiter's orbit. So my father made a prediction that you'd never see something coming in on a hyperbolic orbit, coming into the solar system. The question is, where do you define the solar system, edges of the solar system? It's not where Mula Mula was discovered. It's beyond that. And so unless you see it way beyond the trans-Neptunian objects I talked about coming in, and there's no way to really observe them there, you can't say if it's been perturbed or not.
Okay, cool.
So that's the explanation of it.
Sure. Thank you.
I had read about that a few months ago, but I'd forgotten the name of it.
When there was eruption and all the water and debris was expelled, the aftermath of that, we have a change in the Earth's diameter. Is that related to the 360 versus 365?
I don't think the Earth's diameter would have changed drastically. I just think the distribution of mass would have changed. So as it heats up, heavier things would have moved towards the center of the Earth and lighter things to the surface. I don't think the radius of the Earth would have changed that much.
Okay, and then with a lot of material coming out of those underground chambers, does that have any? We just had a big earthquake in Turkey. Is there any impact between those underground chambers in the past and the earthquakes we see?
Yes. And when I talked about the 25 mysteries that can be explained, if you're familiar, around the Pacific is called the Ring of Fire. Lots of earthquakes and volcanoes all around there. And that can be explained by the what happened in the Atlantic and the Pacific. The Atlantic, there would have been a lot of things left launched and then the Pacific would have kind of caved in, like if you took a ping pong ball and pushed your thumb on it, and that would have caused all around the Atlantic, all around the Pacific, lots of earthquakes and volcanoes that we still see today. And Brian Nichols it's about an hour-long video talking about some of those things. His videos are pretty long and detailed. In fact, I want to flip to the, sorry, that's the way this is set up. And his reference is number 6 up there. It's BRYAN. Sir, did that answer your question? Okay, thanks. Miranda's got a question.
Yes, you talked about like how the I guess or what would become the TNOs and the asteroids
Yes.
were going to be in orbit around the Earth, and then because of solar winds and the other two that I forget the name.
Yarkovsky effect and the radiometer effect.
Podium. Velocity would be added to those on like average because of those three things, because they seem like small effects. Just thinking about.
It's a very small effect, but it's constant, and it goes faster and faster and faster.
So it's additive.
Yes, it's a little push, and how much it depends. It depends on. Let's just talk about the solar sail. It depends on how big the sail is. But they are building. They do have satellites in orbit that are using these solar sails. It's a cheap way to move. It just takes a long time to get up to speed. But once you get up to speed, nothing slows you down up there. Or very few things. Unlike when you're driving, you have to keep your foot on the gas a little bit to stay the same speed because the wind is hitting you and there's friction on the wheels. But up there, there's not. You don't have wind slowing you down. So if you get up to speed, you keep moving at that speed, and then you could get pushed a little bit more and you move a little faster.
So with that in mind, how long would it take to break orbit?
What do you mean by break orbit?
So maybe I'm confused, but were you saying that eventually the asteroids would have like had a?
I would think they'd spiral out constantly in an orbit. And when you talk about the thrust, actually I taught a lesson this week on this. There are some satellites in space that orbit, and they have such a thing called an ion thruster. The force of that ion thruster is about the force of weight of one sheet of paper if you held it in your hand. And it's pushing a satellite. But it happens constantly. And these satellites are designed to slowly spiral out in a circle to get to a bigger orbit. And it may take 50 days when you could fire a rocket and get there in an hour. But 50 days and you don't have to use hardly any fuel, it's worth it. But the thrust that these thrusters give is about the weight of one sheet of paper held in your hand. And it's pushing a small satellite. Now, I think the thrust that we're talking about would be greater than that because you'd have a big swarm catching a lot of the sun's rays. A small force over a long period of time can really add up.
find one of your papers and read through it, and you talked about modeling the orbits millions of years into the past and then also forward.
Yes.
Does that modeling take into account these three small forces?
No. No. What I was doing there is I was saying, take all of the TNOs and all the planets where we know they are today. And then with the computer, we went through and analyzed the forces on every TNO from all the large planets and the sun. And I said, what if that force is constant for a little time? Where will that TNO be in a day? And then reanalyze what's the force from all of them and where will it be in one more step, and one more step, and one more step. And I did that for all 1,600 of these. And I propagated it forward millions of years and backwards millions of years to see how long that distribution of the right city node took until it was uniformly distributed. And I said, yeah, they'll be uniformly distributed in just a few million years.
Would you have a prediction how much those small forces would change your conclusions?
Well, the problem is, how do you model those small forces? And I don't know how to model those. My model was based on Newton's law of gravity, which is a nice, easy equation. If I know the position of the two things and the mass of the two things, I can tell you the force. And my audience was not this group. My audience was astronomers who would say, what do you mean a force? What do you mean? And I never mentioned the hydroplate theory in my papers. It would not have been published. And some people criticize my father's work and say, if it's so good, why don't you publish in peer-reviewed journals? I guarantee you, many more people have read my father's book than read online journals where I've been published. People don't read that stuff. And you don't get published if you mention something like creation. It's not published in a technical journal. It might be published in some journals, but not the journals that I need as a professor at college. But some people who read those realize, this sounds like the hydroplate theory. And I get contacted by people saying, okay. And that's how I kind of got connected with this group.
Does your father's theory explain the ice age after the flood?
I believe it does. And I don't want to, I would probably need to go read up to make sure exactly how, but all that water that's thrown into space, a lot of it comes down as rain, but it freezes, and so a lot of it comes down not as snow, but just ice dumps, huge ice dumps. And the mammoths, the first mammoths, they died from suffocation. Many of them with green leafy food in their mouths. So they were buried very quickly. And yes, I think that would form an ice age. It's also interesting if you get into this book that believes that the Earth rotated after all of this. And in Genesis, I mentioned it earlier in a side conversation with someone, it talks about after the flood, and there was a great wind. And my father looked at that and thought, what's this talking about, a great wind? And let me see if I can pull up something else that relates to this. And Rob, stop me if we're going too long. But he has an explanation, and he actually bounced it off me because it relates to one of the classes that I've taught. Gosh, how did I get out of this? Okay, good. I want to get to the mid-oceanic ridge. Let's go back. So anyway, that would be his explanation for all the ice on the Earth. But if you look at this, now I can see it. Okay, if you look at the, oh darn, it doesn't show up here. Directly below India, there's a trench that goes straight north-south. Almost straight north-south. What caused that? When the Earth rotated in a great wind, there would be a rip. So as the mountains bulged, there would be more mass where the mountains formed, the largest mountains, over like Nepal, by Nepal, that mass as they're spinning, the spinning motion wants that heavier mass to move towards the equator, so the Earth would rotate, and that would come down closer to the equator. Well, that would cause the crust of the Earth to rip, because the Earth is wider at the equator, about 22 kilometers wider at the equator than at the poles. So you can't, it's not a round sphere that can just go like this. It has to move over a bigger surface, and that would cause a rip right at, I believe it's the 92nd longitude, but I'd have to look at that. I was hoping to show you that on here because it's a phenomenon on the ocean floor that's very difficult to explain.
Another question. If you have this ice falling from space, why wouldn't it melt?
Well, I think it is melting still today.
No, but I mean, why wouldn't it melt as it enters the atmosphere?
Just from the heat of re-entry?
Right.
Oh, I think some of it probably did. I think a lot of it did. Yes, I understand what you're saying.
Yeah.
But the re-entry doesn't melt everything. Some things still get in, and it kind of depends on how fast it's moving. I think a lot of the stuff that went into space and came back down did not orbit. To orbit the Earth, you need to be moving about 7.5 kilometers per second. But you can go into suborbital, just go up and come right back down. And the velocity on re-entry is not going to be nearly as great if you're doing that. And so I think a lot of the water probably just went up to high altitudes and came right back down. They're not moving that fast to burn up.
Does the hydroplate theory explain why there's various points on the Earth where the magnetic North Pole has
flipped?
Yeah, has flipped.
Yes, I gave a talk to a group, and they asked that specifically about the area around the Mid-Atlantic Ridge. And then I went back to my father's online book, and the answer was, I don't know, I'll have to look into it. And I went back to my father's online book and looked at that. And Brian Nichols also talks about that. And it was first believed that lots of rocks showed that the magnetic field had flipped. But since then they've shown no, it's just a couple rocks near the surface, not all of them. And so I don't think it has flipped. But honestly, I'm not that familiar with it, and I'd have to read up on it. I was a little hesitant coming to a group like this and thinking, oh, it's Father Walt Brown. Ask him anything you want about the hydroplate. There's so many things about the hydroplate theory I'm not that familiar with. And the thing that impresses me with my father is the breadth of his knowledge. And he also studies a lot more than me. Yes, sir.
A TNO question.
Good.
Someone that you showed in the beginning.
Yes.
I think I found it on Wikipedia, and it said the two segments were 13 miles and 9 miles across.
Yes. And I said it's about 21 miles total, so
Okay.
close to that.
So is that an accretion of dust? Is that one big giant rock that's 13 and 9 miles across?
That picture you saw is the closest we've ever come to it. And no one's landed on it.
Right.
So the answer is they don't really know, but it looks like two objects that came together. Is it? And it's probably not all dust because of the shape that they're in. So the answer is no one really knows what it's made of, but everyone agrees two objects came together.
That'd be pretty big if we expelled objects 13 miles and 9 miles across.
Oh, no. Let me back up. One thing I didn't cover, and I did mention that, like that comet, they said is 72 to 74% empty space.
Okay.
Comets are sometimes referred to as a dirty snowball. It's not the kind of snowball I make. I pack them. It's not snow like you want to ski on. Comets have the consistency of a meringue on a meringue pie, or like shaving cream. So just because it's 22 miles across, don't think of it as 22 miles of rock. Think of it as 22 miles of fluff or dust. And even the asteroids, mostly empty space.
Okay.
From lots of rock piles. So yes, it's easy to look at a picture and say that's a solid piece of rock. That's a big rock that shot up there. I think it's a lot of rocks that came together, and the ones that came together had more gravity, like Pluto. Gravity was able to form them into something that looked like a sphere. The other ones, like Ultima Thule and some of the other pictures I showed, gravity wasn't enough to actually form them into a sphere. And that's why they look like peanuts or something like that.
Question, it looks, going to the moon, it looks like there was a moonshot, as you said, that the exploding Earth, the objects hit the moon. Have you calculated how long it would take to go from the Earth to the moon along with the time it took to orbit to finally hit it?
Yes.
Okay.
What's the number?
Yes.
Don't know off the top of my head, but it's in that paper. It's on the order of about 1 or 2 days.
Yes. That's good enough for me. Thank you. Okay, I was coming up here to announce that we need to, it's 9 o'clock now, so we probably need to break off, since this is the last warning.
I have one
We've
from
got-
Brian Nickel.
We got.
Can I
we got
do
a
that?
Question from Brian Nickel.
Well, not a question, but a comment.
Okay, so,
If I could do that.
we will have one-on-one Q&A afterwards, so if you have any more questions, so we'll make Brian Nichols last word. And then, is that okay if you can ask him later?
Oh, Brian's asking a question?
He's actually commenting on the ridge in the Indian Ocean that is the rip due to the Earth rolling is the 90 East Ridge, about 3,000 miles. Yeah, so, yeah, and thanks, Brian, for joining us tonight. Much of the reason for and then he just commented, much of the reason for the ice age was due to the conditions after the flood, which was warm ocean surface waters and very high continents, which had not settled. And so I'd like to really quickly comment too that, as Dr. Rob Brown mentioned, Brian Nickel has these fantastic videos, and there's 6 videos, I think about 40 minutes each, maybe 50. Fantastic. Just do Google Brian, Bryan, Nickel, HPT, or just do Hydroplate Theory, Brian Nickel. Even if you spell it wrong, it'll take you there. And you can watch his videos. He's got explanations on limestone formation, the Grand Canyon. They're really well done, super well done. And I couldn't get enough of them. I think I watched.
Nice thing is you can pause it and rewind it.
Exactly. So again, thanks, Brian, for joining the meeting tonight.